Hi guys, my name is Henry, and today we want to deal with the topic of permutation and combination. This actually deals with advanced counting. Now, many people had been using it without putting across their definite meaning, but I want to give the difference between these two words. Permutation deals with order, so the order of arrangement or counting is very necessary, whereas in combination, the order does not matter. For example, in how many ways can you arrange the letters A, B, C in a row? Now we have three letters and we just want to arrange them, meaning that each letter will be taking the first position, the second, and that position. Now in this case, the first position can be filled by either A or B or C. It means that we have three possible ways. Now the second position can be filled by either of the remaining two letters, which is equals to two possible ways. That position can be filled by remaining one letter, which will actually be only one way. Now together, the number of ways we're going to have is 3 times this 2 times 1, which is equals to 6 ways. Note, in this case, the second choice depends on the first. The third choice depends on second. The number of permutation of n objects, we have the n objects. Taking R, I want to take R at a time, is defined by mutation n taking R, which is given by mathematically n factorial divided by n minus R factorial. In particular, if the objects we are choosing are different, then we have permutation n such that you'll be having n factorial n minus n factorial. In our case, this one will be n factorial. Of course, this is 0 factorial. In our case, we had our n was 3, so this one will be 3 factorial divided by 0 factorial. We know that 0 factorial is 1, but now 3 factorial is 3 times 2 times 1, so which gives us 6 ways. Now next, if we have a group of 12 people and we want to select different committee comprising 6 people. So in this case, order of selecting the 6 people from the group is not important. Interest is on the actual persons in the committee. That's number of committees which can be formed will be given by combination. So we want to choose 6 from this n, which is equals to our permutation n r. I multiply by 1 all over r factorial. In this case, n is 12 and our r is 6. Remember, we had defined this as n factorial divided by n minus r factorial. Therefore, our combination, that is n r, will be given by n factorial divided by n minus r factorial multiplied by 1 all over r factorial, which in combination we have n minus r factorial r factorial. Our n is 12 and our r is 6, and therefore what we're going to have here is 12 factorial divided by 12 minus 6 factorial 12 minus 6 factorial will be 6 factorial, And what we've seen from permutation is that if I have 3 factorial, this means I get this for 3 factorial. So following this and implementing it here, we are going to have 12 factorial divided by 6 factorial, which is equals to 12 times 11 times 10 times 9 times 8 times 7 times 6 factorial, because 6 can continue until we multiply by 1. You divide by 6 times 5 times 4 times 3 times 2 times 1 for the first 6 factorial, and the next is 6 factorial. I have written this way because I want to simplify this 6 factorial and 6 factorial. Doing your computation, you will get says 2 24 9, yes, 9 24. So you're going to have 9 24 considering the combination. So thank you guys, and continue subscribing for more, so that when I get a new insight, you will be the first one to get the notification. Thank you.